Okay, so for today's class, we're going to be looking at the composition of functions. Now, function composition is basically when we connect two or more functions together. So if we have a function f and a function g, then for some value of x that exists in the domain of g, it will correspond to some output g of x. And if we consider our output g of x as an input for our function f, then we will get some function or some expression such as this, where we have f of g of x. So here g of x is our input into the function f, right? And this is just the composition of two functions f and g. And when we take the composition of two functions, we can define an entirely new function, h of x, right? So basically, when we're taking the composition of two functions, we just have one function as an input inside another function, right? And we can denote this in a different way. So if we have a function h, which is equal to the composition of two functions f and g, so this means this is the function f of g, right? So we have an open circle. This just means that we have f of g of x. So the function g is inside the function of f. This shouldn't be confused with f dot g, right? This is just the product of two functions. This equals to f of x times g of x, right? So this and this are two different things, right? This is just the composition of functions, whereas this is the product of two functions, right? If we have an open circle, we're taking the composition of two functions, right? So if the concept of composition of functions isn't quite clear just yet, we will take a look at a few examples of function compositions. So let's consider a function f of x, which is equal to 3x plus 7. And we have another function g of x, which is equal to 2 times square root of x minus 3. Right, so now we have two different functions, and I want to find f of g of 3 and g of f of 3. Right, so now I want to find these two compositions or these two new functions. So let's start off with f of g of 3 first. So we have f of g of 3. Now, what is this? This is just our output of the function g when x is equal to 3, right? So the very first thing we can do is find g of 3. So we have 2 times square root of 3 minus 3. This gives us 2 times square root of 0, which is just 0. Oops, this is just equal to 0, right? And now we can substitute the value of g of 3 into our function f, right? So we have f of g of 3, which is equal to f of 0 because g of 3 is equal to 0. And this is 3 times 0 plus 7, right? We just substituted our value of x of 0 into our function f. And this just gives us 7, right? So f of g of 3 is equal to 7. Right, so now we have found this composition. Now we can try and find this. Right, so it's a similar process. Now we just find our value or our output of the function f when x is equal to 3, right? So f of 3 is equal to 3 times 3 plus 7, which is 9 plus 7, and this gives us 16, right? So now we can substitute our value of f of 3 into our function g, right? So we have g of f of 3, which is equal to g of 16, because f of 3 is 16, and this gives us 2 times square root of 16 minus 3, which is just 2 times square root of 16, 2 times square root of 13, right? So this is g of f of 3. Right, so now we have found the output of these two expressions, or these two compositions. Now you can see that f of g of 3 and g of f of 3, these two things are not equal, right? We can see that these two things are not equal. So that means that if we have a function f and we have a function g, right, and I find their compositions f of g of x and g of f of x, then these two functions aren't necessarily going to be equal. So we have a function here and we have a new function here from its composition of g and f. These two functions aren't necessarily equal, right? So they aren't necessarily the same function. So once again, if we consider the exact same functions of f and g again, we have f of x is equal to 3x plus 7. We have g of x is equal to 2 times square root of x minus 3, right? So now in this case, we want to find the value of a if f of g of a is equal to 25, right? So now we have another composition of functions, f and g, and now in this case, we have to find the value of our input, right? And our output is already given, we have 25, right? So finding f of g of a first, so we have f of 2 times square root of a minus 3. So this is our input into the function f, and we get 2 times square root of a minus 3 by taking x to be equal to a and substituting it into our function g, right? So g of a is equal to 2 times square root of a minus 3, right? So now we input this expression into our function f. So we have 3 times 2 times square root of a minus 3 plus 7, and this gives us 6 times square root of a minus 3 plus 7, right? So we know, so this is f of g of a, right? And we know the value of f of g of a, which is just equal to 25. So that means this is equal to 25, right? So now we can just solve this equation for a. So we now have 6 times square root of a minus 3 plus 7 is equal to 25. You subtract 7 from both sides to get 6 times square root of a minus 3 is equal to 25 minus 7. We have 18. Now we can divide both sides by 6, and this will give us square root of a minus 3 is equal to 3. Right. So now we can square both sides to get a minus 3, and 3 squared is 9. And from this we can find our value of a, which is equal to 12. Right, so our value of a is equal to 12, and we can check our answer very easily. We can just substitute the value of a into f of g of a, right? So we know that f of g of a, we're taking a to be 12 here. We know that this is equal to 6 times square root of a minus 3, but a is 12, so we have 12 minus 3 plus 7, right? So now we have 6 times square root of 9 plus 7. This gives us 6 times 3 plus 7, which is equal to 18 plus 7, and this gives us 25, right? And so now we see that our output when a is equal to 12 is equal to 25, which is exactly what was given in our question, which means that our value of a is correct, right? So we had 3x plus 7 and g of x. Right, so now we want to see, is g of f of minus 7 defined? Right, so now we want to see if this composition is defined. And in order for this composition to be defined, f of minus 7 has to be defined first. And if f of minus 7 is defined, then g of f of minus 7 can be defined. Right. So now we can first check our function f when x is equal to minus 7. So f of minus 7 is equal to 3 times minus 7 plus 7. This gives us minus 21 plus 7, which is equal to minus 14. So f of minus 7 is equal to minus 14. Right, now we can substitute this value into our function g. So g of f of minus 7 is equal to g of minus 14, because f of minus 7 is minus 14, and this is 2 times square root of minus 14 minus 3, and this gives us 2 times square root of minus 17. Now you should have an issue with this term over here, right? We have the square root of a negative number, and if you remember from the previous class, if we take the square root of some negative number, say minus 17, then this will not be equal to a real number, right? We don't get a real number from the square root of a negative number. Instead, we get something that is complex. We get some sort of complex number that has an imaginary unit involved, right? So this is not valid, meaning we cannot have minus 14 to be in the domain of G. So minus 14 is not in the domain of G. Right? So in this case, our input was minus 14, and we can see that minus 14 cannot be in our domain of G. And we can find the domain of G of x, right? So we have the square root of x minus 3, and if we take a look at the argument of our square root, we see that our argument is x minus 3, and we know that the argument has to be non-negative, meaning it has to be greater than or equal to 0, and from this we can see that x has to be greater than or equal to 3, right? We just add 3 on both sides to get this. So our domain of G is actually x, which is an element of the interval starting from 3 up to positive infinity, and 3 is included in our domain, right? So any value of x that is below 3 will not be in the domain of our function g, and in this case we were taking the input as minus 14, which is obviously less than 3, so it cannot be in the domain of g. So g of f of minus 7 is not defined, right? So working with the exact same function again, now suppose that we have a function h which is just a composition of these two functions. So we have g of f, meaning our function f is inside the function g, right? So now what is the domain of h? What is the domain of h, of this function, right? So we know that h of x is equal to g of f, meaning g of f of x, right? And we know the domain of g. We know the domain of g. We know that x is an element in the interval from 3 to plus positive infinity, basically, right? And we can see from the function of f that the domain of f, so from this function here, we can see that there aren't any restrictions on x, right? X can be any value from the set of all real numbers. So the domain of f is x is an element of the set of all real numbers, right? Now if we find g of f of x, we get 2 times square root of 3x plus 7 minus 3, right? So we have 2 times square root of 3x plus 4, right? So g of f of x, which is just equal to h of x, is equal to this, right? And now we can see that under the square root, our argument is 3x plus 4, and we know that 3x plus 4 has to be non-negative, right? Has to be greater than or equal to 0. So we can find the values of x for which h of x is defined, or g of f of x is defined. So subtracting 4 from both sides, we have 3x greater than or equal to minus 4, and we divide both sides by 3. This gives us x is greater than or equal to minus 4 by 3. Right, so our function h of x is defined when our values of x is greater than or equal to minus 4 by 3. So the domain of h is just the values of x, which is an element of the interval starting from minus 4 by 3 up to positive infinity. Right, so there were no restrictions on the domain of f, but there was a restriction on the domain of g, right? And due to this, our domain of f is all values of x starting from minus 4 by 3 up to positive infinity, where minus 4 by 3 is included in our domain, because, and we can show this by using this square bracket or box bracket.